This video will take a look at Boyle's Law, and we'd like to see how Boyle's Law helps us predict how the pressure and volume of a gas sample are related to one another. Boyle's Law tells us that the pressure and volume of a gas sample are inversely proportional to one another. If we look at the condition over here that's labeled 1, so the starting condition, which is this container right here, we have P1 and V1. The P, the pressure, is being exerted by the force of gravity pulling down on this single weight, and the volume is the volume occupied down here by the being illustrated by the size of the gas sample. And notice that when we move to the second set of conditions, we are doubling the pressure because we're doubling the mass that's being used to exert force through gravity on the gas sample. And notice that the size of the gas sample, the volume, gets smaller. In fact, since we doubled the pressure, we cut the volume in half. Now, one way of thinking about this inverse relationship is that if one parameter goes up, the other parameter goes down. My favorite gas law demo when it comes to Boyle's Law is to put things in a vacuum pump and see what happens. And that's what's going on in this video. It's a short video, so make sure you go and watch it. And with Easter coming up, it actually involves marshmallow peeps. So it's a pretty good video to watch. Now, personally, I'm not a huge fan of using Boyle's Law for calculations. I prefer to approach those types of problems using the combined gas law, and we'll talk about that in a later video. But qualitatively talking about these changes, I want you to focus on this second or this last bullet point. Because of the nature of the equation describing Boyle's Law, this P1 V1 equals P2 V2, because of how everything's just multiplied together and the pressure and the volume have to act in opposite directions, they're going to change by the same factor. So for instance, if you double the volume, the pressure has to be cut in half or multiplied times 1/2. If the volume is cut in half or multiplied by 1/2, then the pressure will be doubled. So let's see if we can apply that idea. The first of these examples says that the pressure exerted on a gas sample inside of a syringe is tripled. So if we triple the pressure, what happens to the volume of the gas? Well, if the pressure is multiplied by 3, then the volume must be divided by 3, or another way of saying that is that the volume is multiplied by 1/3. If you do this by manipulating the syringe, you're simply pushing on the syringe until the volume has been shrunk to 1/3 of its original size. Let's take a look at the second example. It says that the volume of a gas is changed from 15 milliliters to 60 milliliters. If the pressure was originally 400 torr, what is the new pressure? Well, these two parameters, pressure and volume, are inversely proportional to each other. So the volume went from 15 to 60. That is multiplying times 4. So if the volume was multiplied by 4, then the pressure is going to be multiplied by 1/4 or divided by 4. So our new pressure is going to be 400 divided by 4, or 100 torr. To wrap up this video, we looked at how pressure and volume are related by Boyle's Law. They're inversely proportional, so if one increases by a factor of 5, the other one decreases by a factor of 5.